Okay, good evening and welcome to this evening's session. We're getting perilously close to the end now. We've got, including this session, we've got another 4 to go. So this is on electromagnetic compatibility, which is a posh way of saying are you causing any interference? Once again, wait for the presentation to catch up. It seems to be a theme. Come on, Microsoft. So through the presentation, we're going to look at causes of interference, ways to reduce the interference, transmission modes, antennas and earths even, and a good station design. So what is EMC? Electromagnetic compatibility is the avoidance of interference between 2 pieces of electronic equipment. Transmitters can...
I don't know that.
Thank you, Alexa. Sorry. Transmitters can cause interference to other equipment, such as a neighbour's TV or a radio, or even electronic touch lamps, the ones that you just touch the base to turn them on. You need to understand the impact and how to minimise the likelihood of causing unwanted interference. So we're going to look at some of that now. So different interferences. So there is a chance your signals can cause interference to, amongst others, TV sets, computer monitors, public radio systems, cordless and fixed line phones, touch lamps, as I mentioned just now, baby monitors and CCTV, amongst other things. The ability for a piece of equipment not to suffer from interference is known as its immunity. So, well, I mean, as this list says here, there's quite a range of different electronic devices that can be affected by EMC or your ability to put signals out, and they can come from different sources as well. So here's an example of a hi-fi or a home sound system and different ways it can pick up the interference. So obviously you have a hi-fi with lots of different cables coming out of it. You have one going to, or you have an earth cable in the power cable that obviously goes into the wall. You have cables going off to your speakers, and most hi-fi systems have some form of aerial or antenna for receiving public broadcast radio. All these different all these different cables can essentially act as an antenna and receive your signals from your amateur radio station, which causes interference within the main system itself and obviously over the speakers. It's especially prominent at VHF, UHF. Although personally, my personal experience is when I'm on HF, if I'm on 80 meters and I'm putting out my full 50 watts, I actually managed to turn my Xbox on in the next room. So my experience is on HF, but that could be due to the height of my antenna. My HF antenna actually sits quite low for a good third of it. It's not far off the ground. Whereas my VHF, UHF antenna is up above the gutter height of the house. RF interference to digital TV will pixelate the picture and cause breakup to sound. It's worse if it's a weak freeview signal coming from its source, or if the TV is using a signal booster, because that will not only boost the signal that it's receiving from its source, it will also boost any other signals that come into contact with it, like ones coming from a ham radio station. So obviously here we have a picture of a very popular TV show. and it has been interfered with by an external RF signal, and it has pixelated. And you will have a very similar effect, but with the audio, that will break up quite badly, or can break up quite badly. Again, the same picture, just as a bigger demonstration. So, how do we minimize this interference? Well, it depends on the problem. If you move your transmitting antenna further away from where it is causing the issue, that will help. You can reduce the power. The more power you use, the more interference you can cause. You can fit filters or chokes to the antenna and or pickup cabling and as close as to the affected device as possible. So if you've got some speakers that you've identified as the cable between the stereo and the speakers are picking them up, if you put a few turns in the cable and put a bit of electrical tape around it close to the device, that might help. It might not solve it, but it might help. But you can also use filters on mains power supply leads, and you need to address earth problems. We do go through a little bit of earthing in this presentation, but earthing is a huge subject. I've just been studying it myself for the full license, and to be honest, it boggles me. It's a really in-depth subject. However, the RSGB do provide some pamphlets to help with earthing issues. They're free, you can get them from their website. So different types of filters. We have 4 here. You have clip-on ferrites. These are quite common. You can pick them up at radio rallies, etc., or you can order them online. You have a high-pass or band-pass TV filter. You should be able to get these from places like Argos, Amazon, and I believe you can probably get them at Proper Job or places like that. A wound ferrite ring. Again, these are like ferrites. You can get these from amateur radio, where it's gone, amateur radio conventions and things. And very often you'll also notice on a lot of power leads, they've got a ferrite built into the power lead. If you've ever wondered what that little box is, it's essentially one of these built into the cable. Do be aware that homemade filters are potentially dangerous if they are not tested correctly. Okay, you need to make sure that you have built them to do the job you are requiring them to do. So testing for interference then. Remember that your license requires you to test your equipment from time to time. We touched on that in the last lesson. You can use a dummy load, which will allow you to test whether it is your radiated signal causing interference or if the interference is going through connected interface leads or mains. So this down here, this picture is of a dummy load. Essentially, it's a series of resistors, and you plug that in place of your antenna. And what that will do is when you transmit, essentially, you've cut out the antenna, and although it's safe for you to transmit, the signal isn't going anywhere. So that will then tell you if the interference you're causing is radiating from your antenna, or if it's going through the mains, or if it's radiating through another cable from your system. So it's a really useful tool to have. Because, I mean, we've mentioned earth, your signal can travel back down the earth cable into the main system of the house, causing interference to other devices. Modes in EMC. So obviously we've mentioned modes in the past, and different modes can have different effects on the interference you can cause. So FM causes the least interference because it's frequency modulated, not amplitude modulated. It causes a lot less interference. With AM and single sideband, that's amplitude modulated, and that can cause greater interference. Morse or CW can create, it sounds like clicking in, so if you're interfering with a TV, it can sound like clicking on the telly if it's not smooth, or if it's not a smooth signal. And data, although because it's constant, it can be less of a problem than speech, but it can still cause issues. RF earth. Use an RF earth to minimize RF currents leaking into mains and interfering with other mains powered equipment. You may find outside your house, normally near where the power comes into the house, there will be a what's known as an earth rod stuck in the ground. And that's what this picture is of here. It's an earth rod. And it's a copper stake stuck in the ground, at which all the earth from the house's electrics go into. Don't use that stake for your RF earth. You must use a separate one. Don't use radiators and water pipes, because that goes back to your mains earth. Any metalwork in your house goes back to the mains earth. So you must use a separate earth for your RF. So you can use a copper stake in the ground as close to the shack as you can. Obviously, this sort of thing doesn't count for handheld devices, but it's for mains or for base stations. And use a heavy gauge wire to connect it from your transmitter or from your antenna matching unit. This subject of earthing is, or can be, quite in depth. And you may, if you have earthing problems at any point, you may need to do a bit more research on it. I had some RF problems a short while back. I had RF getting into my computer, and it took me a few days to sort it out. I know others have had issues that's taken them weeks, if not months, to sort out. But it is an in-depth and complicated subject. Antennas and EMC. A horizontal dipole is least likely to cause interference on HF. Because this is a balanced antenna, it's connected from the transmitter or antenna matching unit using unbalanced coax cable, and uses a balun to balance out the signal. And the shield of the coax can be connected to an RF earth. For HF, a horizontal dipole is the least likely to cause interference. But there are many designs, and obviously once you've got a dipole up for HF, it's hard to move it to send your signal in a different direction. So there are other designs of antenna that allow you to do that, but when you start using those, you enter into you're more likely to cause interference with other people's devices and other devices within your own home. So a station design then. Use good quality cables and connectors. Try not to buy the really cheap stuff. Use the best quality you can afford to actually put your station together. If you can, have a good RF earth, and use mains and RF filters wherever you can. So in the diagram here, we have a filtered main socket going into our power supply unit. That is then connected up to our transmitter, which is then filtered with an RF filter into our SWR unit, which is very often incorporated within our antenna matching unit. This diagram has the antenna matching unit connected to an earth rod, as well as its balanced antenna. There are some rigs, some transceivers that have antenna matching units in. Most transceivers will also have an earth on the back of it as well, and nearly all antenna matching units will also have an earth socket on the back as well. Very often it's just a little screw that you put you put your cable round and screw it into bolt it into place. So antenna positioning. In an ideal world, consider setting your antenna as far away from houses and other antennas as possible. As high as possible as well. Height is everything with antennas. For HF, a balanced antenna, ideally a horizontal dipole, will generate less interference than other antenna types. So an example of a balanced antenna setup. An HF antenna sited away from the house and TV antenna. The actual antenna here is the other end of the garden. The feeder has been buried underground and is also connected to earth near the shack. This station has used good quality coax, and the RF earth, as I just said, is next to the shack. An end-fed antenna setup. This is an unbalanced antenna. It is fed from the end of the garden. So you'll notice the coax runs, again, underground to the other end of the garden, and the antenna is fed from that end because it's taking the feed point away from the TV antenna. And that way you're going to cause less interference. Again, the RF earth is close to the shack. These are in ideal circumstances. I know a lot of people live in areas where this isn't ideal. I know I certainly do. My antenna sort of is wrapped around my house and goes right past my TV antenna. In fact, it doesn't go past it, it goes over the top of it. I don't get interference on telly. This is an example of a poor EMC setup. So it's fed from an upstairs shack. There's no RF earth. It's hard to get an RF earth if your shack has to be upstairs. If you can do it downstairs, that's not practical for everyone. There are other ways of dealing with it. The feed point of the antenna is in proximity to the TV antenna, so that's quite likely to cause interference there. EMC and Neighbours. To avoid disputes, it pays to be helpful, diplomatic, and cooperative. So if you get a neighbour come around complaining, oh, your antennas are causing interference with my TV, don't get defensive about it. You try and be as helpful as you can. You still want to continue your hobby, but of course they still want to watch telly or listen to their radio or use their touch lamps or whatever it is they're doing. Work with your neighbour to conduct a few basic tests. Normally, these problems can be resolved quite easily and fairly cheaply. Your neighbour may also consult Ofcom, for which they will have to pay. And they may visit you and want to test your equipment. They are at perfect liberty to do that. Before Ofcom get involved, when the neighbour first complains, it might be helpful to keep a log of when you transmit and ask them to keep a log of when they receive the interference, because the interference may not be coming from you, but it is a very common trope for someone to go, oh, look, that person's put up an antenna, I'm going to receive interference from them, and then go and complain. Ask them to keep a log of when they're receiving the interference. You keep a log of when you're transmitting. and you can compare the logs and say, well, yes, that is me, or no, that isn't me. If Ofcom get involved, they may ask you to keep a log and ask your neighbour to do the same, just to see for the same purpose. If you've already done that, they're less likely to ask you. Okay. EMC and cars, or any vehicles. Care is needed when using a transmitter in a car. I must say, before we go over this, most of this is if you are installing a permanent set station in your car. If you are literally just, you've got a mobile unit and you're just popping a mag mount on the roof and plugging it into the cigarette lighter socket, this isn't so prevalent. But it's if you're installing a permanent system into a vehicle. Professional advice should always be sought for all vehicle installations. The vehicle owner, be that you or be that another member of the household, is responsible for ensuring that any radio installation is compatible with the vehicle's electrical and management systems and does not affect vehicle safety. In these days, a lot of vehicles, if not most, have some form of computer inside, and they don't always take kindly to having other electrical devices attached to the vehicle. You may need to inform the vehicle insurers that the vehicle has been modified. Again, if you're just using a mag mount and having something on the passenger seat whilst operating, plugged into the cigarette lighter, that isn't a modification. A modification is when you have electrical systems going through the fuse box attached to the battery and having an antenna installed permanently in the roof or something like that. Any tests following mobile radio equipment installation should be done while stationary and with all vehicle electronic systems operating before any on-road tests are carried out. Note, the vehicle ignition and battery charging systems can cause electrical interference to reception on mobile radio equipment. Most radios nowadays have something called a noise blanker. That helps sort that issue out, but doesn't completely, necessarily all the time. So there's advice on reducing interference and antenna setup is available from numerous sources, including the RSGB, as I mentioned earlier, and in various antenna books and from clubs. If you have any issues, approach your local club. They should be able to help. The RSGB offers a range of free EMC leaflets, some of which are designed to be given to neighbours, which could help if you have an issue with a neighbour. Advice is available from the RSGB EMC committee via their website. So in summary, you will need to understand the symptoms and causes of EMC. You need to have a good RF earth, and you need to use the right type of antenna and good quality cable. Understand the correct station setup. Realize that FM is less likely to cause interference than other modes such as AM and single sideband. Understand the type and correct use of filters. Take care with in-car amateur radio installation. And when resolving problems, keep a log and get advice from the RSGB or a club or another radio amateur who's had similar experiences. There on social media, there are loads of groups actually out there to help with this sort of thing, amongst other amateur radio issues.